In this video, we're going to look at dipole-dipole interactions. This is one of the three intermolecular forces. Dipole-dipole interactions are the attractive force between two polar molecules. So let's use sulfur difluoride as an example. Here's the Lewis structure of sulfur difluoride. You can see that there are 4 electron domains around the central atom, so the electronic geometry is tetrahedral. There are 2 bonds and 2 lone pair, so the molecular geometry is bent if we only consider the bonds. Here I've drawn the dash wedge kind of geometry or image of sulfur difluoride with the lone pairs indicated. Looking at the electronegativity difference of sulfur and fluorine, we can assign partial charges along the covalent bonds, and we see that there's a partial negative charge associated with the fluorine and a partial positive charge associated with the sulfur, resulting in a net dipole moment of the molecule as indicated here. The attractive force, the dipole-dipole interaction, is due to the alignment of this dipole moment of this sulfur difluoride molecule with this sulfur difluoride molecule. Here we have the partial negative charged region interacting with the partially positive charged region of the other molecule.